My name is Vincent Bentley, and today we'll be calculating the radius of the neutron with theoretical physics for the first time as far as I know. Let's begin. If you place a neutron in a box like so, you make sure that its velocity is 0, its mass will be 939.56, like so. And so the total mass inside this box will be 939.56. If you wait about 14 minutes, the neutron will break up into a proton and an electron. The proton mass will be 938.272 when its velocity is equal to 0. And the electron's mass will be 0.511 when its velocity will equal 0. The funny thing is, when you add the proton plus the electron inside this box, it comes out to be 938.781. But the original box had a total mass of 939.56. Although most people would say that's close enough, in physics this discrepancy causes a lot of headaches. Hopefully we will solve some of those headaches today. The only mass equation which allows for the mass to change when it's placed inside a box is Einstein's relativistic mass equation, which I show right here. What this equation basically says is, if you know the mass of an object when its velocity is equal to 0, and you give that mass a velocity, its mass will change according to this equation. Let's try to do that for our electron here. If you remember, the electron mass that I stated before was 0.511 when its velocity was equal to 0. We're going to do something interesting and give the electron a velocity of 0.918 times the speed of light, which we will place into here as appropriate from the equation here. When we calculate this using a calculator, we end up with a mass of the electron to be 1.288. Notice that the mass originally of the electron when its velocity was equal to 0 is 0.511, and the mass of the electron when it is moving at 0.918 is 1.288. Again, most people would say that would be negligible, but it's like taking a 51-pound person and changing them into a 128-pound person. I don't think a lot of people would say that was negligible. So the mass of the electron when it was not moving has increased quite a bit if it is moving at 0.918 times the speed of light. What we're going to do now is take our big proton, which has a mass almost 2,000 times the electron, and place it in the center and have the small electron orbit around the proton, which would make sense from an orbital mechanics perspective. If we look at this system in this box, notice that the mass of the proton is not moving, so it remains the same as it was in the previous plate that I showed you before, and that is 938.272. Of course, the electron is moving, so it will have not a mass of 0.511, but a mass of 1.288, which is the moving mass. By the way, I denote the bar above the E's as electron that is moving, and there too. If we take the mass of the proton here and the mass of the electron that's moving right here, and we add these two together, we get 939.56. That number might seem familiar to you because it is exactly the mass of the neutron that I stated before. If you would like to see that, I can show you that right here in the original plate, which was 939.56 was the mass of the neutron originally. So it was fortuitous that we let the electron orbit the proton at 0.918 times the speed of light. Well, let us take a look at the new box here. Here's our proton, and here's our electron. And now we will assume that it forms a neutron. We will assume that the electron orbits at a radius r and at a velocity v. We will need an equation that governs this behavior, and the equation looks something like this. Basically, this equation tells you that the electric force on the electron makes the electron go around the circle, the proton. This equation asks for a few variables and some constants. The first constant is K. That is an electrostatic constant, which we will tell you in just a second. We will need the charge on the proton and the charge on the electron, which have an absolute magnitude which is equal. We will need the radius of the orbit, the mass of the moving electron, the velocity of the moving electron, and the radius of the orbit again. So this is our perspective equation. We will now put in our numbers that we know for that equation. What we know is that we can look this constant up, K, in a book, physics book. It is 9 times 10 to the 9 approximately. The charge on the electron and proton, the absolute magnitude, is 1.6 times 10 to the minus 19. The radius, of course, we do not know. That's what I told you we would solve for at the beginning of this lecture. The mass of the moving electron, I did not put in the units that we put before. I changed the units from MeV per speed of light squared, which is the reason I didn't mention them before for you beginners. But you seasoned physicists will know what that means. I have now changed them into kilograms, the mass of the electron, moving electron. And if you take that 1.288 MeV per c squared and change it into kilograms, you will get 2.31 times 10 to the negative 30 kilograms. The velocity also I have changed from 0.918 times the speed of light. We will need that in meters per second. And when you take 0.918 and multiply it times the speed of light, which is 3 times 10 to the 8th, you will get 2.754 times 10 to the 8th. So we've plugged all our people that we know in. And, of course, we have left the people we don't know as variables, because we can solve this with some simple algebra, or you can go to a Google Algebra Solver and type all this up, and it'll solve for R for you if you cannot do the algebra. When you solve that, whichever method you decide, you will get a radius of 1.32 times 10 to the minus 15 meters. And that is what we originally decided we were going to try to calculate today. It is interesting to note that this right here is the equation for the Compton wavelength of the neutron. It is Planck's constant, the mass of the neutron, and the speed of light. Planck's constant can be found in every physics book. The mass of the neutron can be found fairly easily too, from Google or a physics book. And the speed of light I have mentioned before is 3 times 10 to the 8th. When you type all these numbers in a calculator, you also get 1.32 times 10 to the minus 15, which lends a little bit of credence to our calculated value right here by another method. And that ends my lecture. I hope you enjoyed it. Thank you. Bye.